Hey, sixth grade. So our screencast today is on factoring expressions, and our objective is I can model and write equivalent expressions using the distributive property. So we're going to be drawing a lot of models today, and for example 1, you need to write out the directions because you're going to see problems that use directions like these, and you need to understand what they look like and what they mean. So use the model to answer the following questions. Here's our model. So we have one large bar and we've divided it so that we have here 2 times 5 and here 2 times 3, and go ahead and fill in the numbers. Make your model look exactly how mine looks. And so now we're going to use the model to answer some questions. So the first question is, how many 5s are in the model? 1, 2. So we're going to write 2. How many 3s are in the model? 1, 2. All right, so far so good. And what does this expression represent in words? If I were to write this out using words, I would say, well, I'm adding this part to this part. So if I'm adding, I can say the sum, and it's the sum of this group plus this group. So I'll say the sum of two groups and I have 2 groups of 5 and 2 groups of 3. Two groups of 3. Okay. And so an expression that we could use to write that out, and we kind of see it reflected up here, would be 2 times 5, 2 times 3, and I'm adding them together. Now that's a totally correct answer, 2 times 5 plus 2 times 3, but it would also be correct if you put those parentheses around it as well. You don't have to put the parentheses in order for that to be correct, but I just wanted to point it out because I know to some of us it makes sense that we would have to multiply these first before we add. All right, so let's look at another example. This one looks really similar. Now look at how this one is laid out. Go ahead and draw that model. So how many 5s are in this model? 1, 2. And how many 3s? 1, 2. That's interesting because it's the exact same as the model that we just looked at, even though this model looks a little different. There are still 2 5s and there are still 2 3s. But let's try and write this one using words because I bet you that there's something about it that's different. So we have 2 groups. We kind of see this group here and then this group over here. So I'll start by writing 2 groups. Of the sum, because we're still adding, of 5 and 3. In other words, I'm adding 5 plus 3, and I'm doing that in 2 different groups and adding them together. So what expression could we use to write that model? There are actually 2 different ways you could write this. So we could do, and actually kind of 3 ways. 5 plus 3, 5 plus 3, and we're adding them together. So that's one way. We could also throw the parentheses in there to show that we add both of those groups first and then add them together. We could also use multiplication. So we could do 5 plus 3 times 2. And we could also write the 2 at the end, but since we're going to be talking about the distributive property, it's really smart to write the 2 in front because with the distributive property, remember we see letters and numbers at the front of the parentheses that we would distribute to the inside of the parentheses, or share with the inside. So we'll get in the habit of writing that at the front. Let's keep going with our lesson. So is that first model that we looked at equivalent or the same to the second? Yes, both of those are equivalent. Both expressions, I do want you to write this out, both expressions have 2 5s and 2 3s. Therefore, 2 times 5 plus 2 times 3 is the same as 2 times 5 plus 3. What relationship do we see happening on either side of this equal sign? Okay, so on the left-hand side of the equal sign, 2 is being multiplied by 5, and then by 3 before adding the products together. So here we're multiplying 2 by 5, we're multiplying 2 by 3, then we're adding together. On the right-hand side of the equal sign, what's happening is the 5 and 3 are being added first and then being multiplied by 2. So we'll write that out in words. And we can kind of even make a little T-chart to organize our thinking. So on the left side, 2 is multiplied by 3 and by 5 before adding the products together. And on the right-hand side, what's happening is the 5 and 3 are added first, and then multiplied by 2. So let's pause for a second. What we just did was we determined if those two models, those two expressions were equivalent to each other. We said yes, and we showed mathematically, visually here, what was happening in those. This part, we used a verbal or written method to explain what was happening. These are all kind of the same questions, but this one is explaining more linguistically or with our words, and this one is explaining more with math terms. So this is like, the left side of your brain, the right side of your brain, and it relates back to our learning styles. We're gonna keep going here. What's the name of the property that is used to say this idea? 2 times the sum of 5 plus 3 is equal to 2 times 5 plus 2 times 3. Hopefully you remembered from our objective. That is called the distributive property. That tells us that we distribute the 2 that's on the outside to everything inside the parentheses. So the 5 is a term, the 3 is a term. We're going to distribute the 2 to the 5. So we're going to do 2 times 5, and we're also going to do 2 times 3. All right. Example 2, we have another model. So go ahead and draw this. This time I'm using A's and B's. So here we have 2A and we have 2B. What does the model represent in words? So this is showing A plus B plus B A plus B plus B. And I could write out the, plus is Plus. It also is showing 2 A's plus 2 B's. It's also showing 2 times A plus 2 times B. So there are really 3 different ways that you could say this and be correct. A plus B plus B, 2 A's plus 2 B's, and 2 times A plus 2 times B. And so now, what does 2A mean? Well, 2A means that there are 2 A's, or 2 times A. And that's A's 2 times A. And we see that here and here. How many A's are in the model? 2. And how many B's are in the model? 2. 1, 2, 1, 2. What expression could we write to represent this model? Well, we could write 2 times A, and we're adding that to 2 times B. And we have one more model here. So we're going to use this model on the bottom of this page. And our last set of questions for example 2 are going to be here on this one. So you're going to see this model looks really similar to this one. Kind of like in example 1, we have 2 similar models. So in this model right here, how many A's are in the expression? 2. And how many B's are in the expression? Also 2. I see 2 A's, 1, 2, and I see 2 B's, 1, 2. So we're gonna write 2 and 2. What expression could we write to represent the model? Okay, well, I could show A plus B plus A plus B again, or I could write that using the distributive property as 2 times A plus B. Are the 2 expressions equivalent? Yes, equivalent means the same. Both expressions slash models include 2 A's and 2 B's. Therefore, 2A plus 2B is equal to 2 times the sum of A plus B. All right, and so now we're going to move on to the last part of our lesson here, where we are applying our distributive property. So we're going to use GCF and the distributive property to write equivalent expressions. So sometimes in math, you'll be given an expression, remember no equal sign, and they'll ask you to write an expression that's equivalent or has the same value, or they might even give you like multiple choice and say which expressions are equivalent to the one that we give you. So what is the question asking us to do? We need to rewrite the expression as an equivalent expression in factored form, which means that the expression is written as the product of its factors. The number outside of our parentheses would be the greatest common factor. So what does this have in common with this, or what do the 2 terms have in common? Well, they're both being multiplied by 3. So if we expanded each term, this would look like 3 times F plus 3 times G. Our GCF would be this 3, or the greatest common factor in each term is 3, So the 3 goes on the outside of the parentheses, and f plus g will go on the inside, like this. And this would be our final answer. It's like we're pulling the distributive property back out. So we pulled the 3 out from here and threw it on the outside of our parentheses. This is showing 3 times the sum of f plus g, and that's equivalent to this, because then if I shared this 3 with everything inside, I'd have 3 times f plus 3 times g, and that's what we started with. So they're equivalent. Okay, so let's look at this problem. 6 times x, or 6x plus 9 times y. So we need to rewrite this expression as an equivalence expression that's in factored form, which means that the expression is written as the product of the factors. The number on the outside of the parentheses would be the GCF. So if we wrote this out in expanded form, we could say 6 would be like 2 times 3, and 9 would be 3 times 3. Because I can't just look at this one and pull out a 3 like this problem, right? The numbers are not the same. So I'm going to break them up into their factors. I'm going to find the GCFs. So I see 3's in both of them. The GCF would be 3. So here I really have 2 times 3 times x. That's for the 6x. And then here I have 3 times 3 times y. This is for the 9y. Okay, so here's my first term factored out. Here's my second term factored out. And so now I know that my GCF is 3. That's going to go on the outside of the parentheses. And then I'm adding on the inside of the parentheses. And what am I left with? Well, I used this 3, and I used one of these 3's. So now I'm left with 2 times x on this side and 3 times y on this side. All right. 3 times c plus 11 times c. Is there a greatest common factor in this problem? Well, let's expand it out and see. This would be 3 times c, and I'm adding that to 11 times c. Hey, I see a c in each side. So sometimes your variable can be your greatest common factor. I'm going to pull the c out and put that as my GCF. C times, and what am I left with? I use that. 3 plus 11. And then finally I have 24 times b plus 8. So I'm going to expand each term. I'm going to break it into its factors here. So I know I can do 6 times 4. This would be 2 times 3, 2 times 2. And then I have times b on that side. And 8 would be 2 times 4, and that's 2 times 2. So if I rewrite this as a whole expanded expression, I would have 2 times 2 times 2 times 3 times b plus 2 times 2 times 2. That comes from my 8. So this part comes from my 8, and this part comes from my 24b. I'm still adding them together here. My greatest common factor that I see in both sides, I really see a 2, but I have 2 times 2 times 2. I see that 2 being multiplied 3 times, so I can pull that out from this side if I see that there too. 2 times 2 times 2, 2 times 2 times 2. Hey, well that's 8. So I'm going to pull 8 out. 8, and then I'm left with 3b on this side plus nothing is left on this side. So when that's the case in algebra, we write 1, because that's really like the whole thing is being multiplied by 1. And when we're doing the distributive property, we have to fill in terms on each side of that plus sign. So why is there a 1 in that parentheses? If you're like, Miss Ngali, that was confusing. When I factor out a number, I'm leaving behind the other factor that multiplies to make the original number. So in this case, when I factor out 8 from 8, I'm left with a 1 because 8 times 1 equals 8. And this is related to the first two examples because we saw that we could rewrite the expressions by thinking about groups. So we can either think of 24 times b plus 8 as 8 groups of 3b plus 1, or as 8 groups of the sum of 3b plus 1. So this is showing that 8 times 3b and 8 plus 1, when we add those all together, that it's equivalent to this expression up here, 24b plus 8. In other words, if I distributed this 8 to everything inside the parentheses now, 8 times 3 is 24b, and then 8 times 1 is 8. So I get the expression that I started with up here. All right, so you are going to have some practice problems. I'm going to write them with you. I do want you to write these out on a separate piece of paper and turn them in before you look at your packet questions. And so you will have to do this entire page, A through H, then evaluate each expression when x equals 3, y equals 4, and g equals 6. And then how can you use your knowledge of GCF and the distributive property to write equivalent expressions. So you can work with your teams. Let's fill in A. You're going to have to apply the distributive property to make equivalent expressions. So this is just like we practiced. For A, I want you to do 7x plus 7y. B is 15g plus 20h. C is 18m plus 42n. D, try 30a plus 39b. For E, I want you to do 11f plus 15f. Letter F, do 18h plus 13h. G, 55m plus 11. And then letter H, try 7 plus 56y. On these problems here, you need to substitute in what I give you for each letter. So here, every time you see an X in one of these problems, you need to plug in 3 or substitute 3. Every time you see a Y, plug in 4, and every time you see a G, plug in 6. Don't forget to answer this question at the end. Thanks so much.